Hey everyone, welcome back with a new lecture with method development and validation. In this training course, I try to explain everything about method development, validation and verification, and also about measurement uncertainty calculation for sampling and for analysis in a very simple way to be easy to understand by the beginners and also by the experienced staff. And as per your requirements, I'll explain again measurement uncertainty in details from the beginning up to the end, but especially for analysts who from chemistry background. Measurement uncertainty, how much you have a doubt with your analytical measurement, and that tells us about the quality of the measurement or accuracy of the measurement, because there is no measurement with 100% accuracy. There should be some factors that will affect the accuracy to be deviated from 100%, because for every measurement, even the most careful one, there is a margin of doubt. This margin of doubt, these are the factors affecting the accuracy, shall be quantified with the high confidence level, and this margin of doubt is the measurement uncertainty. This margin of doubt can be expressed in these two terms: width of margin and at which confidence level. The width of margin, which is the value added to the final result to compensate all effects during the measurement, which is measurement uncertainty. So you will add the final result plus minus measurement uncertainty, and at which confidence level, how much you are confident that this result lie in between this range. So this result plus minus the measurement uncertainty shall be delivered at a high confidence level, which is mostly 95%. So you will write final result plus minus measurement uncertainty at 95%. As example, if you have 50 microgram per kilogram plus minus 10%. So 50 microgram per kilogram plus minus 10% from the 50, it will be 5. So from 45 microgram per kilogram up to 55 microgram per kilogram, and you have 95% confident that the result lie in between this range, and this is the margin of doubt. And by calculation this margin of doubt, which is measurement uncertainty, and adding this to the final result at high confidence level, you compensate all effects during the measurement and you give them the real concentration but in between range. If you didn't calculate all of these effects on the analytical measurements from sampling up to getting the result and adding this as a value, adding these effects as a value, which is measurement uncertainty, to the final result, it will deviate the accuracy of the measurement, and that will not be the real concentration of the analyte. So the measurement uncertainty is a parameter associated with the result of measurement, is a value added to the final result. So parameter associated with the result of measurements that characterizes the dispersion of values or variation between results that could reasonably be attributed to the measurand, which is the quantity being measured as concentration of the analyte. So parameter associated with the result of measurement, as I explained before in the method validation, that you will have replicate analysis, and for each replicate, for the low level, mid level and high level, you will calculate standard deviation. This standard deviation will express at the end the measurement uncertainty, because standard deviation characterizes the dispersion of values or variation between result, and that will be considered at the measurement uncertainty, or will be used after that to calculate the measurement uncertainty. So this is the parameter associated with the result of measurement and will be added to the final result at confidence level 95%. As we have in this example, if the result is 50 microgram per kilogram plus minus 10% will be the measurement uncertainty, so you will calculate 10% from the 50 microgram from the final result. It will be 50 microgram per kilogram plus minus 5 microgram per kilogram. That means your result in between the range of 45 up to 55 microgram per kilogram, and this is the real concentration of the analyte at confidence level 95%. You are 95% confident that the result lie in between this range. So you should know now, why do we need to quantify measurement uncertainty? Because measurement uncertainty is a value added to the final result to compensate all effects during the measurement, from sampling up to getting the result. During sampling, extraction steps or sample preparation, analyst's competencies also will affect on the measurement. Instrument will have an effect on the measurement, and other equipments used during the extraction or during the sample preparation. These equipments, you can get the measurement uncertainty for these equipments from the calibration certificates that will be explained after that, inshallah, and others also. All of these considered as a source of uncertainty that will affect on the accuracy of the measurement, that may deviate the accuracy of the measurement, so should be calculated or quantified to get a value. This value will be added to the final result. This value will be added to the final result to give you the actual result for the analyte in the matrix, or we can say valid result. It will give you valid result within acceptable range after addition of this value or measurement uncertainty, and that will provide also higher confidence to the customer.